All right, we are almost done. We just have this and the back to go. So two problems here, and then we'll do the back all together. So once again, we are starting out. This is in factored form, just like this one was. So you can go straight for finding the zeros. You really shouldn't need a calculator. Since it says x minus 2, you do the opposite. So this will be a positive 2. This would be a negative 3. A negative 1, and a positive 3. In this case, since there's no exponents, that means all the exponents are 1, meaning all of these multiplicities are 1. So 2 has a multiplicity of 1. I'm just going to write M1. Negative 3 had a multiplicity of 1. Negative 1 had a multiplicity of 1. And 3 had a multiplicity of 1. So there you go. There were 4 zeros. All of them had multiplicity 1. Which, when you graph them, let's see, 2, negative 3, negative 1, and 3. It means it's going to go through all of them, kind of like that. Just to kind of get a general shape of it, this is positive, which means it is going to end going up. So, like, automatically, I know it's going to go here, and all of them are multiplicity 1, so it's going to go through here. It'll curve, it'll go through here, it'll curve, it'll go through here, it'll curve, it'll go through here. It's not going to like bounce off of any points like that or like that. It's going to go straight through, straight through, straight through, straight through. I just don't know what the minimum is. I don't know if it gets this low or if it gets that low or if it gets this high or that high, anything like that yet. So I'm going to put in the calculator and find out in a second. Literally 1 second. There we go. I already typed it in right here. I press graph. And there it goes. And holy cow, it looks like they go off the page even. So it definitely was not like that. It was like this. But, it has the same zeros I already put. Let me adjust this bit. Okay. So, and behavior, you can see here that they're both going up. You can verify here. This is positive, which means it should end going up like we said. It goes through this, down quite a ways, up, and ends going like that. So the end behaviors will both be positive infinity. And we'll just find those minimums again. Once again, it's a second calc, and we'll just go to minimum. And we'll find this one over here. So somewhere to the left, somewhere to the right, and a guess. And there you go. Negative 2.2, comma. Well, it says 20.967, which when it rounds is going to be negative 21, which is unfortunate because usually when you have whole numbers here, people assume it's an actual whole number. But this is supposed to be a decimal. And negative 21 is kind of off the charts, so we're just going to have to go, boom, comes back up like that. For local max, there we go. This is on the left of the max. That's on the right of max, somewhere over there, and here we go. Local max looks to be 0.398, so that's 0.4. And then 19.8. And once again, 19.8 is too far up, so I'm just going to go up like this, come back down to here, and we'll find the last minimum. Left, right. So 2.6 is another minimum, and 4.9 negative. So that one is on there. 1, 2, 3, 4.9 will be about there. So we'll go down, hit that, go through there, and yada yada. So down, boop, boop. I already drew this kind of part, so it doesn't matter as much. It's supposed to go steeper, but whatever. It's an arrow. It's going to infinity. And there you go. That's that problem. For the last problem, this is going back to not being in factored form, so you have to do what we did on the first couple of problems. It looks like this is positive and the highest exponent is 4. So like if I wanted to get a general idea of what it looks like, you could right now. It's positive, so it will end going up. It's an x to the 4th, since that's even. The other side will also be going up, and it's probably going to look something like this. It might not, it might just go down and then up, but it might go up and down twice. But either way, it'll definitely be pointing up on both sides because it's positive and even. So let's do maximum positive roots. That is the one where you see how many times it changes positive to negative. Alright, so you're just pausing and trying it before moving on. That is up to you. This is positive, this is positive, this is positive, this is positive, and this is positive. So they are all positive. How many times does it change? They're all positive. It never changes. However, if you take all of the odd exponents, so like this is the 3, that's the 1, and change those, even stays positive, odd changes negative, even 2 stays positive, an odd 1 changes it to negative, and then this stays positive. If you count now, this is one change, that's another change, that's another change, and that's another change. So it actually changes 4 times. So there will be no positive roots, but there could be 4. So there's either going to be 4 here or some amount less. So maybe there's none, maybe there's 2, maybe there's 4. We'll see. In terms of possible roots, once again, see if you can remember how to doing it. Pause the video, give yourself a second to think. Do you remember how to do possible roots? Keyword is possible. This is going to be the P over Q thing. In this case, P is going to be 12, and Q is going to be 1. So if you weren't able to find them yet, once again, pause. See if you can remember what to do here. You got the 12, you got the 1. What do you do to find the possible? Look at everything that goes into 12. 1, 2, oh my goodness, 2, 3, 4, 6, 12. Everything that goes into 12 divided by everything that goes into 1, which is just 1. So every single combination of dividing is going to be 1, 2, 3, 4, 6, 12. And these will be plus or minus. Like that. So when I plug this into the calculator, it'll be some of those numbers. And let's see which ones. Okay. X to the 4th plus 4x to the 3rd plus 7x to the 2nd plus 16x plus 12. So let me double check. Okay. So like I said, there's going to be none over here, but there's probably going to be some over here. Sure enough, there you go. So it looks like there's 2. And those 2 real ones look to be like -1, 2, 3. So -1 and -3. So I can put those down. They are going straight through this and straight through that, so both of these have a multiplicity of 1. And end behaviors, you know, they're both going up. I already did that over here, so boop. I'll go ahead and find the minimum right now just because I'm thinking about it. So there you go. Hi. 1 second.